Hi, welcome back to my channel. This is Dr. Anbu Selvan. In this video, I will walk through the concept of polymorphism, right, and its implementation step by step. So in my previous video, I already explained how inheritance, right, can be deployed or can be implemented. So we go back to the practical level. Okay, so this whole description, right, will actually is about giving information right to implement inheritance, and we get to see there are a lot of classes actually involved here, like person, student, employee, and under employee we have faculty and staff, right? So you can see here, right, we need to implement several classes, and this is what actually we did in the previous practical. And then you also get to see my date. All right, so this is another class. Okay, and this class, right, should be linked up with the other class, right? Probably through association. And then we have enum, right? So enum is like a kind of class. So usually the practice is when you have a lot of constants variables, right? We tend to actually declare them as final. And a better way when things get actually more complicated, more complex, the better way probably we create a enum with constructors. Okay, and that actually would make the usage of enum, right, more flexible and more robust. Okay, I will talk a little bit on enum, all right, shortly, right, before I proceed to polymorphism. So let's go to the code now. Okay, this is what actually we implemented previously, right? And you get to see here we have employee. First of all, is a person. Okay, and this is declared as protected. This is actually access modifiers. Okay, and then this will serve as a parent. And under this, right, you will have employee. Okay, extends person, and then you have student extends person, right? And faculty and staff, right, both actually, right, will extend employee, right? So you have two levels of inheritance. The first level is the person, second level is the employee, right? And you get to see all these actually entity classes where we should have instance variables, the core instance variables, all right, that characterize each entity class, and you have getters and setters, and you have constructors, and of course a method, right, to display the content of an object. So all these actually entity classes, right? Okay, on top of that, we also have my date, okay, integer, year, month, and day. Okay, and this particular class is associated. All right, if you look at here, we have employee, right, as association, right? Okay, you have my date and date hired, all right? So it is connected to the employee, right, through association. Okay, I already discussed in detail about association. Talking about has a relationship, uses a dependency, aggregation, and composition, right? So next we look at the enum. We also created the enum, right, previously. Okay, and we find that you have a name for this, and for each of symbolic constant, right, is represented by a number. Get to see the number. Okay, and then you have one instance variable, and then you have getter, and this is the constructor. So this constructor, right, cannot be public or protected, has to be made private, right? So that is the actually the rules, okay, when you create enum constructor, right? So this technically, right, this enum, right, when you run, right, it will behind the scene, it will create an object by itself automatically, right? It's done, right? So the system actually will create an object for us, and this object is actually, it's not dynamic because static. All right, so it will be there until you shut down the application. So an object, static object, will be created. All right, and it'll be there, right, for longer period of time, right? The dynamic object is different. All right, it will be there for a shorter period of time. All right, so static object is different. So we actually created two enums, right? One is the rank, the other one is for the status, right? Okay, so if you want to know the value of this, okay, the value for each symbolic constant, right, then we need to use this getter, right? Get action, right? We can also extract this, we can also extract this, right? It's not an issue. We can get both actually, right, from the client actually. right? Okay, so moving on to the next, we're talking about polymorphism, right? So we will use the practical 11, all right, solution, all right, to carry out, all right, to complete this practical 12, right? So ensure you have done the practical 11. Now, next we look at this, right? Polymorphism is a very important concept. It's actually game changer, right, in a object-oriented paradigm. So I'll explain to you, right, how polymorphism, right, can be super useful, right, in one particular situation. Now, before that, we need to understand, right, how and why polymorphism, right, is being used and how it can be used, right? Some concepts, right, we need to know. Now, let's look at this, the first one, right? Create one custom defined method to display the details of object in person class, right? Employee class and faculty class, right? Override this method in the subclasses. Okay, so we need to understand what is the concept of override, overridden, and overriding, right? Now, first of all, right, when I say custom defined method, is a method that the programmer actually right creates, right? Probably need to fulfill certain requirements, probably need to implement a particular feature and so on, right? So the programmer, right, will create a method, so-called custom defined method to display the details, right? So obviously we have one method, right? As usual, in every entity class, right? We use this. This is actually is the ready-made method, I'll call it built-in method that allows us actually right or clients actually right to display the content of an object, right? So right now you get to see that you have a method called toString, and this can be used in every entity class. All right, so this is super useful. And whenever you use like super toString, right? So what will happen? It's going to call the person's toString over here, right? It'll call this, okay, and then it will display the current instance variable belongs to the student, right? Okay, so right now the student actually has this class with the person one, two, three, four, five instance variables technically, right? Okay, so the relationship between student and person is always one to one, is a relationship. Okay, so student is a person, right? But not the other way around. Person is not a student, student is a person. Okay, now moving on to the next. So what I'm going to show you right now is we will do this custom defined method to display this person class, employee class, and faculty class, right? So we're going to target only these three particular classes. So what I'm going to do, right, is I'm going to create a method, all right? So this method is a custom defined, right? So what do you mean by custom defined, right? We can simply create an additional method, right? Just to display the content of the object, right? So this is what I'm going to do right now. So um, the toString, right, is I would say the toString is useful, but just to show that how we can actually right create one custom defined method, right, on top of the other toString. So what I'm going to do, right, is perhaps I can just use this toString display objects in person, employee class, and faculty class. Okay, so let's look at this person class, right? So we put here person class, right? So you have what we call, this is the parent method, right? Okay, so as we know, right? So what I'm going to do, right? I'm going to create, maybe I'll just say this is a custom defined method, right? To display content of the object. Okay. Now, if you don't want to use the toString, it doesn't matter. You still can use this. Okay, content of object. All right. So what I'm going to do, right, is I'm going to have public string and I'm going to have display details. Okay. Now this is actually happening in the parent, right? So what I can do, I can just copy this the entire thing, okay, and place it here, right? So right now, let me reformat the code. Right. Okay, now this display details, right, is actually serving the same purpose as this, all right? But the only thing, right, is we create this method, right? This is the built-in thing, right? Let's look at this, right? Display details. So I need to actually replicate this, right? Probably in other classes as well. So the person is already there, right? So I'm going to have this. This is actually the method that we created in the person, right? This is the parent, all right? So when we go here, let's look at this employee, okay? So next we need to look at employee, right? So I need to implement only this in three classes. Of course, we can implement in other classes as well, right? So employee. So right now we're gonna have, okay, click string display details. Now, the moment actually you complete this, the skeleton of this particular method, right? Now you'll get to see something happening right on the left hand side here. You can see the line number 53, right? So can you see that you have some sort of like uh, indicator, right? That actually giving hints like saying that overrides method in person, right? So which means that this is the method that we have in the parent, right? And sort of like creating the same method, right, in other class, right, the child class, right? So the system actually saying that, oh, this method is already defined in the parent, and you're creating the same method, all right, with the same name actually, right? So as we know, right, the relationship is like one to one, means that employee is a person, both are the same, right? So if you are creating the same method, all right, so that is the uh, issue here, right? So the system has to know, right, okay, later on, right, when you display something, right, okay, the system has to know whether this comes from the child or from the parent and so on, right? Because the relationship is such, all right, employee is a person. So I'm going to have this, if you look at here, we have display details. And what we need to do, right, we just need to put here override. That's it. Okay. So this is override, right? So I will explain to you about this concept, overridden and overriding. Okay. Right. So if you look at this this method, it is quite similar to the here. The only thing that I need to have is just copy this, okay, and I'll paste it here. Okay. So now let's discuss about this concept, this overridden and overriding, right? So this, let me complete the other one as well, faculty. And over here, right, I'm going to have public and string display details. Okay. And this is override. And we're going to copy this and paste it here. So you may be actually wondering, right, why earlier, right, in the previous practicals, right, I didn't actually discuss in detail, right, the override. So now is the right time actually to discuss about this. Even the built-in, right, you get to see that it's override there, right, because the parent object, right, the parent object, which means that in Java, right, means that um, sitting at the top hierarchy, right, is the object, okay, parent object, right? So the parent, right, at the sitting at the top in the Java entire JDK, right, is the object, all right? So in the object class, right, you already have this uh, method called toString, right? And in the faculty, right, when you start using the toString, so this is actually the parent class. This is a child class. So all the classes that you're building, right, is actually inheriting the parent class, all right, which is the object. So in the object class, you already have a method called toString, and you start actually using that particular method, right, in the child class, which is the faculty right now. Definitely, right, the system, will say that, okay, this method is already actually defined in the object. So please put override. Okay, so I'm going to put here, I actually put this override. because only for that reason, right? So because this method is already found somewhere else in the object class actually, right? So why we need to actually override this, all right? So next, the concept of we call about overridden and overriding method. Okay. Now let's look at this display details, right? So this display details, right, you have some sort of specific implementation. It's different codes compared to the person, right? If you look at here person, right, you have a different implementation, all right? So I will say, right, this kind of implementation may be quite general. This kind of implementation probably more specific because it's a child class, right? So what we are trying to say, right, is this particular method, okay, this particular method, right, okay, display details is going to override this, all right, override this, okay. So this method will be overridden by this display details, right? So later on when it comes to like executing and so on, right? So when we say this method is overriding this one, which means that the system will give more importance for this compared to this, right? Because this method, right, will be overridden, right? So in this case, this is, we call it overridden method, right? Is that the method that that you allow the child class, right? You're allowing the child class, right, to have more specific implementation. It's called overridden. And over here, right, we will say that this is overriding, okay? Overriding. So the overriding, right, will take place in the child class, whereas overridden, right, will take place in the parent class, right? So this is the concept, right? Overridden and overriding concepts, right? So if you allow a method, right, to be uh, to have more specific, all right, to have more specific implementation by the child class, right, then we call it overridden. So you're allowing that. It means you're allowing this method, right, to be implemented, right, in having more specific implementation, all right, then we call it this overridden, right? And this is method is like overriding this method. Okay, so this is how actually the overridden and overriding works. Okay, so later on I will show you, right, the implementation and so on, right? So right now, so what I'm going to do right now is we go back to the driver. Okay, we go back to the driver and let's see, right, how we can actually execute this, right? So we go to the driver. Okay, so when you will run this, um, okay, when we run this, right, you get to see new staff, John, and everything, right? Okay, we provide all this value, the constructors, and then we print the staff and then print the faculty. That's fine. Okay, so what I actually want to show you, right, is what happens. Let's say I have employee, all right, display details. I have person, and then I have faculty, right, with display details, right? Okay, so right now, let's say I'm creating um, an array, static array, right, which can be used, right, to store, right, objects, right? So I can just use maybe I'll just put person one equals to, maybe I just put new person. Okay, maybe I'll just put, okay, fine. So when you write like this, right, what will happen, right? You're creating an array, static array, right, with a size of 10. And this array is capable of storing, right, all these objects, employee, faculty, person, staff as well, right? Because the person is the parent, right? So this is the good thing when you define the reference variable, right, or the data type as the parent. So usually, right, we will define this, right, we will use the super type or the parent reference variable, right? So if you use, let's say, employee, right, you can only store objects of employee, faculty, and staff. What if, let's say, you want to store various types of objects? including person, right? Then we can use the more general reference type. Okay. So if you use the, for example, staff, so what will happen? You can only store objects of staff, right? You cannot store objects of person, faculty, and so on. So I want to store, right, various types of objects. So I put here person. So that is the reason, right? So I put here person. Okay. Right. So right now, what I'm going to do, right, is I'm going to take this, store this, right? Okay. So I'm going to create a new object. So maybe you can just put person. Oops. Okay. So person one. Okay. So new person. So let's say this and comma. Right. So let's say copy this. Okay, copy the entire bit. Right. So let's say, okay. So what other things I need to store? Phone number, email. For the person, you only have four, right? Address, phone number, email, right? So going back here, um, I can just store all this. Okay, this is done and semicolon. Right. So I'm going to create an next object. So I'm going to have employee, okay, and new employee. So for the new employee, right? So perhaps let's copy this. I can have address, maybe a different one. Okay, and for employee, right, we need to provide several details, right? Office, salary, date hired. Okay, office, salary, date hired. So I need to provide this information as well. So what I need to do, right? Perhaps I can just provide here. Okay, office name. Okay, and perhaps the salary. Okay. Now for salary, right? Perhaps I can just use double. Okay. So when I change this double, right, everything has to be changed here. Yeah, double. Okay, and receiving also double. So now what happens? We have salary, and of course we need to provide some other information as well. So we're going to put new date. So maybe I just provide here 202563. And we also need to provide other things as well, right? Because let me check employee whether this is good enough. Yeah, only we don't need any other information, right? So that's it, and we can just like this. Now I'm getting this double, right? So we need to go back to the employee and we need to change this, right? Supposed to be a double here. Okay. Okay. back here, then no issues. Okay. Now, next, I'm going to have maybe the faculty, right? New faculty. So what I can do, I can just copy this one. Now, instead of creating this, I can just this faculty one. Okay. So I'm going to comment this part and add this. Okay. Oops. Okay. So now we're going to walk through this, right? To trigger this, right? To call this display details, right? So this display details, right, exists in employee, faculty, and person, right? Okay. So I'm going to go here, person as well. Yeah. Right. So for loop. So I can have person and then if okay p right not equals to null display details, right? So I'm going to run this, right? Okay, so you get to see, right, person, it shows a different implementation, therefore you get different output. This one you get a different output, and this one you get a different output. Okay, so this display details, right? Okay, the system will know exactly, right, which class it has to call, right, to look for the display details, right? And because we already store everything into this, the system know exactly, right? Okay, and this is what we call method binding, right? So when you while the program's running, right, only then, right, the system will figure out, okay, display details, right, um, should be called, all right, will determine, right, it will determine which class, all right, that it has to look for the display details, right? So you find that first, right, if you look at here, person, okay, and then you have the one or then two. So the system know exactly the first one is the person object, second one is the person employee object, and faculty. So when you run through this, right, you know exactly, right, okay, the first object person, it has display details, second it has display details, and the faculty also has display details. Now what happens if we put, let's say, right, for example, okay, let's say I'm taking this, right? So let's say we'll have this. I'm going to put right now the staff. Okay. So the staff actually, right, doesn't have display details, correct? You only have the two string, right? So let's see whether we can get whether we'll get runtime error or not. Okay. Okay. So you don't get any errors, right? So by right, you should be getting error because the staff, right, doesn't have display details, right? So it should be, you're calling a method, right, which does not exist in the staff, right? So this is the beauty of polymorphism, right? Means that if let's say the child class doesn't have the display details, right, then you're going to look up the parent employee, right, direct parent, immediate parent is employee, right, and happen to be there, right, is a method display details, therefore it will call this. So this is also, we call it method binding, right, which means that the system doesn't know, right, doesn't know that the staff um, uh, doesn't know that staff, right, doesn't have the display details, right? So only while the when the program, right, when you execute the program, only then, right, the system will get to know, oh, okay, this particular class, right, staff doesn't have display details, all right, so therefore, right, I need to look up the parent. Okay, what happens, the employee also, right, doesn't have display details, then you will look up its parent, the immediate parent, which is the person, all right? So this is what we call method binding, right? So the system doesn't know in advance, all right? It only knows, right, when you run the program. So while the program is running, right, only then, right, it will discover this, all right. It will determine or make a decision, right, which class, all right, it has to call, all right, for the display details, right. So method binding, right. So this is the difference, method binding. Method matching, right, means happening before you run the program, right? The system is already know, okay, I need to call this class for this method. That's it. Method binding is the other way around, right? It doesn't know, right? Only when you run the program, right, the system uh, will get to know, right, which class has to be called for a particular method, right, to trigger a method. All right. So that is the difference between method matching. So this is happening during compile time. This is actually happening during runtime. So it's two different things. All right. Right. Along the way, right, I'm actually explaining concept, right, one by one. Dynamic binding means, right, okay, dynamic binding. Let me show you this. Okay. As I mentioned just now, right, um, this polymorphism, right, facilitates dynamic binding, right? So we saw, right, the driver, right, is actually attempting to call display details, right, in the stuff. It doesn't have. So some or other, right, the system has to look for the display details and trigger the display details, right? So it will look for the parent, immediate parent. It has the employee. So the system will try to bind. So once the system has bind a method, right, then it can actually execute the method. So the binding has to take place. So this is happening, right, before running the program, right? This is happening right after running the program. Um, Not before running the program, right? So it's called dynamic binding, right? Means that the system doesn't know, right, in advance, all right, which method, all right, has to be called, right? So this is what called dynamic binding, right? Happening during runtime or while the program is running. Okay, moving on to the next, I actually explained most of the concepts already. Next, we look at this compare between dynamic polymorphism and you have a static polymorphism. So we'll do this right now. Okay, next, I'm going to actually target one particular class, all right, to explain the static polymorphism, right? So let's say I'm going to go to the student class, okay, student class. And simply I'm going to type in like this. Okay, so I'm going to explain about overloading. This overloading, right, is associated with static polymorphism. Okay, overriding, right, is associated with dynamic polymorphism. Okay. Polymorphism, right? So I'm going to create two methods. For example, GPA, and have Boolean is weighted GPA and double dot GPA. Supposed to be a Boolean, right? Now, assume, right, some universities, they practice this, I mean, weighted CGPA or GPA, right? Okay. And we want to calculate the GPA, right? So maybe based on the weighted or not weighted GPA, right? So I'm going to have double sum equals to 0, 0. And for double I, sum equals to, okay. So I'm going to have another method with the same name, GPA. I'm going to have only this and the implementation. Uh, right. So now I'm going to have a message as well. Okay, system out. Let's provide here your weighted GPA is give a space, and then sum divided by GPA length. So I'm going to copy this and paste it here. So I can just provide here. Here doesn't have the weighted, right? So assume, right, your GPA is okay. Now, if you observe carefully here, right, why we are saying overloading, right? So overloading means, right, having the same method name, right? So if you look at here, the same method name, but they are different in terms of the parameters here, okay, in terms of the parameters, right? So the number of parameters, right? So both are different because here only have one parameter and here got two parameters, right? So the overloading, right, can be implemented um, by having different method signature. So this is the method signature, right? So this one got nothing to do here, right? The method signature means refers to this part, all right? So you can actually have a variation of GPA, all right, in terms of um, different number of parameters or different data type, or the order also, right, can actually the system will be able to write and differentiate between this method, right? So three things: the number of parameters, the order of the parameters, and also the type of variables, data type. Okay, so you can play around with these three things, right? In order to have a lot of the methods having the same name, right? You can just, the system will be able to differentiate, right? So when you play around with any one of this or more than one. Okay, so right now we want to see, right, how actually we can invoke these methods, right? The dynamic or not, it's not a dynamic polymorphism, it's a static polymorphism. So we go to the driver now. Okay, so for the, in order to invoke, okay, uh, static polymorphism. So what I'm going to do, right, is I'm going to call these two things, right, these two methods, right, in a different way, right? So I'm going to have here, this is for the static polymorphism. Okay, so I'm going to have this method binding happens during compile time. Because before you run the program, the system already knew, right, which method has to call, right? So I'm going to have new student, okay, and I can just put GPA, and I can just provide here 3.5, maybe 4.0, 3, and 3.0. So I'm going to have one more calling the GPA, but I can have the front two. So can you see that we are calling the same method, right? But different in terms of number of parameters. So before you run the program, right, the system, right, sort of like already figure out, right, which method it has to call. Because you got two variations here, right? One is this one, and the other one is, having just one parameter, right? So the system will try to match the method signature. So here we have only one, right? So we'll try to match this. It's matching here. Whereas this one, you got two parameters. So it's actually matches this. This is what he calls static polymorphism, overloading concept. Means having same method name, but we can play around these number of parameters or data type or the order, right, of data types. Okay, so that is the what we call static polymorphism, right? So when I run this, okay, and you get to see here, your GPA is this, your weighted GPA is 3.2, and so on, right? Okay, so this is how actually it works. Okay, static polymorphism, right? So now you have a clear understanding, right? The difference between static polymorphism and dynamic. So dynamic means actually happening during the runtime. The system doesn't know in advance, right, which method it has to bind, okay, in order to call the method, right? So it will figure out while the program is running. Okay, so we call it dynamic binding, and this dynamic binding actually facilitates the polymorphism. Okay, right. So I already explained this method matching. So method matching is actually here. It's trying to match. Here you got one parameter, you got two parameters. All right. So method binding is different. Okay. So method binding happening during the runtime, right? Um, so you'll know exactly, right, which method has to call, right? When you do the method matching. Method binding, right? The system will figure out, right, which method that it has to call based on, the availability of certain methods in the parent and the child, right? And this is what you call overriding concepts. Okay. Now, all this I already explained. Okay. So next, we talk about casting objects instance of parameter, right? And then later on, we'll do the abstract and then the student, right? So next, I'm going to go here. Right. So now casting objects, right? So now this is a very important thing that we need to know, right? So just like ordinary primitive data type, you also have this concept can be applied, okay, to objects as well. Explicit cast. Okay. So example like person P1 equals to new student. This is implicit casting. Okay, implicit casting, right? So this is the child, but the parent, you're using the data type with the parent, right? It's possible, all right? So the system automatically, right, will not complain anything because the parent, right? This is more general reference type. So you can actually accommodate all the child classes, no child objects, no issues. So this is what you call implicit casting. Okay, so the system knows exactly, right? So what happens, right, if you put P1, okay, and you get to see here uh, display details. You see the person here, right? The P1 is actually belongs to the person, right? So now what you are seeing here, right, is the disadvantage of this. This is what we call upcasting, right? Right. So the P1, all right, can only call methods, all right, referencing the person only. He cannot see, right? So he cannot see the student methods, all right? Because the student method you have GP and everything, right? He can't see, right? Because the reference is belongs to the person, right? So you cannot see methods in the student, right? So in order to see the methods in the student, right? Okay, so what we need to do, right, is, for example, right, I want to call this GPA and everything, right? So what I need to do, right, I need to do explicit casting. So now student equals to student P1. This is what we call explicit casting. Okay, so now we are changing the data type of the person to the student. It's downgrading, right? So we call it explicit casting, right? So now the S1, right, can see all the methods belong to the student. Can you see that? You have GPA and everything, right? But of course, you cannot see. Um, can you see that? We also see a display details as well, right? Okay, because the student, right, you already have here, right, student doesn't have display details, but you can look up the parents display details, right? So you can just put display details, right? It's possible. Okay, so here they mentioned, right, cast may be removed by changing the type of P1 to student, right? Which means that why not just use student, right? why you have to do the casting, right? So this is just to demonstrate, right, how the reference type of more general can be downgraded, can be converted into a another type, which is the student, right? So this is what you call explicit casting, right? This is implicit casting. Okay, so implicit casting means, right, the moment you put new student, right, definitely, right, you will get a reference of student, right, and you're changing that to the parent, right, which is the person. So it's done automatically, right? We call it implicit casting, right? So the reference of this, right, is converted automatically to the person. So you call it implicit, right? Okay, so I can just run this. So when I run this, I'll be able to see display details coming from the okay. It makes sense to get null because you didn't provide any value there, right? For the student, right? Okay, you need to initialize the parent, which is the person. You need to provide all this information, but you didn't provide, right? Okay, so that is why you get null, right? So to probably I can just provide all this. Okay, uh, status. Uh, just provide this. And I need to provide one more as well. I think it's the rank. Okay, so rank. Um, okay, so if you look at here, the student, sorry, status, not rank, status, rank. So status, we can go here. Yeah, we can provide any value there, right? So over here is integer. So I can provide here driver. I can just provide here 2, for example. Okay, status. Now when you run this, you get to see this, right? Okay, this for the student, right? Okay, so this is how actually, right, the implicit and explicit what you call casting works. Okay, so the next thing that I want to explain is the before we do the 7, I'll do this first. Student class to add equals methods. Okay, equals. So I'm going to go here and start adding this method, right? So this particular method, right? Um, it's very popular. Okay, very popular, right? Uh, to have. Okay, because we want to see matching. We want to compare the objects, right? So what we can do, right, over here, here, okay, equal. Right? So this method equals, right, public boolean, okay, equals object. Okay. So this is object is a class, right? Is the I call it the super parent of the in JDK, right, or in Java, right? So this method is already exists in the object class. So I need to put here override because you're going to have a different implementation, right? Your own implementation, right? Right. So I'm going to put here if is instance of student, then return check equals. Maybe I just provide name actually. You want to compare into the in terms of the name, okay, and else return false. Okay. Now, what I'm going to do right now is I'm going to create another object in the driver. So you already have this equal. So we want to compare these two objects. Let's say student object, right? Student 1 and student 2, right? In terms of their name, whether matching or not, all right? So this method will be useful. right, equals. So what I'm going to do, right, I already have the this student, right, student one. So I'm going to have one more, call it this student S2, and you're going to provide all this information. Okay. So okay, right. And I want to check whether these two objects are same in terms of name, all right, not in terms of memory address, right? So what I can do, right, I can just check this system out. Okay. So I'm gonna have, maybe I can just have S1 whether equals or not, equals one S2. Okay, so when you run this, it's false, not same, right? So what if, let's say I change this to Kenny, right? Both same, true, same, right? So we can compare objects in terms of name or ID, whatever things we can do, right? So that is why this is super useful, right? Boolean equals, right? So you return whether true or false. It matches means then you return true. Doesn't match, then you return false. Okay. So what exactly you want to match, right? You want to compare. So here I put name, right? You're comparing this, okay, this one, right, against um, this one, right? So you're comparing this S1 here, right? It's actually referring to this part. Okay, comparing against this S2, right? Represented here. Okay, so you're trying to compare these two, right? So now what is the purpose of instance of, right? Because we want to compare, these objects of student, right? Not objects of employee or faculty, right? So we put this condition, all right? We put this condition, right? Okay, so what happens, let's say, right? Can we say that? Okay, can we try this system out? Okay, is it S1 instance of student? Let's say yes, true instance. So what happens? Let's say I'm taking this person 10. Okay, person 0. False, right? Because uh, this object person is different from the student, right? Okay, so you're telling that whether the object reference, is it belongs to the student? No, the person 10, right, actually belongs to the person object. Okay, so what if, let's say, I have person one is employee, right? Okay, is it instance of, you still get false. Okay, so what if, let's say, I put here person? It's true, right? Because person one, right, is employee. Employee is a person. So it goes through the chain of between classes, right, in inheritance hierarchy, right? So no matter what you put here, right, if you put S1, okay, you still get true, right? Because S1 is actually is the child class, and this is the top was the parent, okay? And what if, let's say, I have compare between faculty and employee. So this is the child, this is the parent, right? So faculty is instance of employee, right? So I'm going to put here employee, and over here, right, I can just put person, faculty one, let's say faculty one. Okay, so you get true, but not the other way around. No? Employee, let's say we take the employee. Okay, person 1 1, right? Person 1 is an instance of faculty. False, right? So always take note that, okay, in order to use the instance of, right, either should be the same object or the parent's object, then you'll get the true, right? So that's how it works, right? Instance of. Okay, so this part is done. Casting done, just now implicit and explicit. Next, make person class as abstract and create one abstract method in the person class, revoke the codes. So right now, what I'm going to do, right, is I'm going to go to the person. Okay, so right now I'm going to make this as abstract person. Okay, person. Public class, right? See public class here. So you have public class, right? So you have abstract. Now, public abstract class, right? No, the reason, right, we use abstract here, right, is uh, when things become more general, right? Okay, it will not be useful to create um, objects that are actually too abstract. For example, person, right, is not really meaningful, right, compared to the student. Student is more practical, more meaningful, something that we can quantify and so on, right? So person, all right, is too abstract. So in order to ensure, right, that we should not create object of person, you just put there abstract. So the moment you put abstract, right, what will happen, right? You cannot create object of person. You can't no longer actually, right, can create object of person, right? So that is the reason, right, we put abstract, all right, to the impact is you cannot create object of person, cannot, right? So what is the usefulness, right? When you don't actually, you're not able to create a person object, that's fine because all this you can pass down, right? All this information you can pass down to the child. So there is no need actually, right, for someone to create an object in order to utilize this. Not really required. All this can be passed down to the child. So therefore, right, what we do, we just create abstract here, right? So you cannot create object person, right? So you get an error here. Can you see that? You're getting an error. It mentions that person is abstract, cannot be instantiated, means that you cannot create an object. So I'm going to comment this, right? You can't do that. Okay, let's see other things. Okay, right? So this becomes abstract. Okay, so you cannot actually create an object like this. You cannot use the new, right? Next, what is more important, right, is I will create a method called abstract method. Okay, abstract method. And what it does actually, right, is abstract method. Okay, so I'm going to create abstract method just like string last time, a simple one, right? Abstract method, right, is a method where we don't have any implementation. Only you have the method name and signature. That's it. No implementation. So you call it abstract method, right? When you put abstract method, right, you have to ensure, right, that the class is abstract. Okay, so you can have an abstract class without abstract method, but you cannot have a method, abstract method, without actually defining here abstract. All right, so abstract method, all right, you can have uh, not necessary to have abstract method, but when the moment you put abstract method, right, then you need to put here abstract, right? So what if, let's say, I remove this, all right? So you'll get probably an error here, mentions that, right? Abstract method in non-abstract class, right? Cannot, right? So you need to put abstract. Okay. So once this is done, so what is actually happening, right, is the moment you put abstract here, right? you're sort of like forcing, you are forcing, right, the child, right, to have the implementation for that method. You're forcing, right, class type. The implementation, right, should be done in the child class. So this is the implication. You're forcing, right, you're forcing the child classes, right, to have the implementation for this. So what I need to do, right, so immediately you get this error, right, must be either declared abstract or implement abstract method, right? So what I need to do, right, is well, here I have so many child classes, right? Okay, so what we can do, right, is first of all, right, I'm going to have the student first, right? So I can have the student also have problem, right? So I'm going to have implement the method, right? So right click, generate, implement the implement methods, all right? The class type, that's it, right? Okay, return what? I can just provide a simple message here, student class. Okay, right. So this actually this method, right, is actually an abstract method found here, right? Abstract. Okay. But over here, right, with the full implementation. And what about the employee? Okay, so employee employee. Okay, so you can have over here, right, it complaints, right? Okay, so what I can do, right, I can just implement that method, show the implementation. So you're going to have implement methods, and over here I can just put from employee class. Now once this employee class, right, has its own implementation of class type, right, so the rest of faculty, right, is safe, all right. So over here you don't have to, like, it's not being forced, right, to have the implementation for the class type, because the parent, right, which is the person, right, it only actually, right, enforcing, right, the immediate subclass, that's it. Okay, because under employee you have other subclasses, right, they're actually not being forced, right? So the immediate subclass is being forced. Okay, so that is the implication. All right, so right now that's it. Even staff also no issues, right? Okay, so this is the purpose of what we call the abstract. In some cases, right, what we need to do, right, we need to force the child, right, to have the implementation, all right, of a particular method. So this is how we can actually enforce this. All right, we can enforce this by using the abstract method in the parent. All right, so the immediate child, right, has to have the implementation. All right. Okay, so we go back to the driver now. Okay, and you get to see here this, right, display details and so on, right? Okay, so on top of that, let's say I'm going to have also system out. Okay, and class type. Yeah, right. Employee class. Okay, employee class. So you happen to be, this is employee, right? All this will be employee class, right? Okay, class type. Right, so if faculty and staff doesn't have the class type, right, so if you don't have, the system will look up the immediate parent. So immediate parent has the class type, right? Now what happens, let's say, right, the employee doesn't want to implement, right, this class type. So what we need to do, right, is we need to make this as abstract. Okay, abstract string class type. So we can put that, and over here, right, it will be this. And as usual, this one we need to make it abstract. So this is what will happen, right? If let's say the employee, right, doesn't want to implement, right, where you want, it wants to actually enforce or force the its child classes to have the implementation, then what you need to do, right, make it this abstract, and then this one abstract class. So now the faculty, right, has the responsibility to have the class type, and also the staff. no choice. Okay, so that's how it works, right? If you don't want to implement, right, from the parent, right, that's enforcing to have the implementation, you can actually delegate or enforce, right, your child classes, right, to have the implementation. You can just actually, right, delegate the thing, right? So right now we keep it simple. We're gonna have that. Okay, class type. That's it. Right. Need to map that. Okay. This is okay. Done. Right. Okay. So I already explained all this. Okay. So next I'm going to show you, right, something that is very useful, why we need to use the polymorphism, right? Okay. So let's say, right, you have a situation, right, over here, um, where uh, where you have to um, calculate, or you have a different algorithms or different calculations, right, to calculate the net pay, right, for faculty. This faculty means academic staff lah, right? Staff means office staff, right? Different calculations, right? So and you want to actually let's say we don't want to have we do it in a traditional way, right? So let's see how it works, right? So what we need to do, right, is as usual, I can actually implement, right, okay, the calculations, right? So what I can do, right, is I can go to the faculty, okay, and this one faculty have a different way to pay, right? I mean calculate the pay. So I'm going to have public table, okay, pay, net pay, let's say, right? Net pay faculty. It's an example, right? And I'm going to have return this salary equals to maybe this salary, okay, and this salary minus, let's say, 11%. Okay, this is the net pay for the faculty, right? So for the staff, I'm gonna put here net pay staff. So maybe it's like why I need to put this, return this salary, maybe 10%. Just an example, right? So we go to the faculty, right? So of course, in real world, you have a different calculations and so on, right? So now we assume, right, you have to construct two different methods: net pay faculty, and then over here, right, you have staff, net pay staff, right? So because of different calculations, and what happens, right, is going to uh, call these two things. Okay, so I'm going to go here and let's say this is without polymorphism. Okay. So what I have to do, percent, maybe I can just put here percent, percent one. Employee, faculty, and staff. Okay, it's supposed to be, maybe I put P1. Uh, oh, it should be inside. Yeah. Okay. Okay. P2. Right. Right. So now, what I need to do, right, is if I want to call, right, if I want to call faculty, right, this one, okay, because in this array, right, you got so many different types of objects, right? Okay. Employee, faculty, you could have other things as well, student objects, for example. So what I need to do, right, we need to filter that. So I need to put this p2 get class, okay, equals, let's say, faculty class, right? Then, so what I need to put is system out. So I'm going to call this, I need to do the casting as well, faculty, okay, and I can just put p2 and pay faculty net. So I can just remove it. So can you see that what we are doing, right? If faculty class, right, because the P2, right, has different types of objects. When it's the object class equals to faculty, right? Okay, P2 get class means get the class name. It matches the faculty class, only then you call this, because netpay faculty, right, belongs to this class, faculty, right? So you cannot be calling this method, right, from other classes, cannot. You get runtime error, right? So that is why you have to do this, and also you have to do the casting, because the p2, right, reference variable, right, is person. You need to downgrade, so you need to do the explicit casting, and you call this, right? If you don't do this, right, the p2 cannot see this, because the p2, right, reference variable belongs to the person. Then the person doesn't have this net pay faculty, right? So the same thing I have to do, right, for, okay, if let's say is staff, okay, and you have staff and you call this staff. Fine, right? So now when you run this, uh, okay, what we are getting here, null pointer. Oh yeah, all right. Not only that, right? Because we need to do this checking as well, right? Because you got 10, right? So you need to put this as a p not equals to null. So I need to have this p2. So when you run this additional, let me check this. This is opening. Okay, this is opening. This I need to have one more, right? Okay, right. So now when you run this, yeah, right. So you get this is the amount after different calculation, right? Okay, that's fine, right? So can you see that how difficult hassle is this, right? You're calling a different method, this is a different method, all right? The method is different, and you got to like do the explicit casting, many things you're doing, right? So what if let's say with polymorphism, right? Okay, so what I'm going to do, right? I'm going to create interface. I can use the inheritance concept interface, right? To do the polymorphism, no issues. So I'm going to have salary calculation. Okay. So over here, right, I'm going to have extract method. So I'm going to put here public double pay. It's supposed to be interface. Okay. Salary calculations. So can you see that it's a different symbol interface? So now actually I can apply this to the employee, employee implements salary calculations. So when he implements means then the employee must implement um, the salary calculations, right? This method, right? So what we need to do, right, is so right now um, we need to make this class is abstract because we don't want the this particular um, class, right, to have the calculations because employee is very general, right? So you have the faculty and then staff. So you can make it this is abstract, okay, and implement salary calculations, generate. So I'm going to have, well, if you don't want to have, okay, you can also do it like this, no issues, you know, pay and all those things, all right? So uh, you can enforce this or you can have a default implementation also can, all right? So right now, what I'm going to do, right, is maybe I want to enforce, all right? So I'm going to have abstract, okay, and then I'm going to have the public, okay, double pay abstract. So now you need to, you're forcing, right? Okay, you're forcing the child, right, to have that. So now the employee, yeah, this one cannot, you, you cannot actually create an object with this anymore, right? So I'm going to comment this thing. Okay. Person and employee cannot, you cannot create an object because you already put abstract up there, right? So now what we can do, right? We can go to the staff. Okay, can you see that? Abstract. So implement generate, implement methods. Okay, so you can have that. So I'm going to copy this. And of course, you have the faculty, generate methods, done. Okay. Now let's look at the impact, all right, when you start using this, right? So you have the same name, can you see that? Pay, same name, and staff also have the same name, but you have a different implementation. That is overriding concept, right? Okay, so we go to the driver class now, right? So this is what we did earlier, right? Without a polymorphism. So now you see with a polymorphism, right? Okay, so what I need to do, right, is I can just copy this entire thing. So maybe I just put okay, son. And over here, right, is if P is null, that's okay, right? So over here, right, I can just provide if um, P2 instance of, I can just use this instance of employee. Okay, so I don't need this anymore. Need. So this one I can maintain same. This one no need. And this will be, that's it. So can you see that the code is much more cleaner? So reformat the code. Okay, so now you find that only during runtime, right, the system will try to figure out, okay, this pay, right, should be calling which class, right? it doesn't know, right? So it's a dynamic binding, all right? Uh, so you're applying polymorphism. This is more flexible, right? Okay. So when you run this, you're supposed to get similar kind of results, same, but the way actually we do different is here, right? So what we are trying to do, right? Whenever you start using polymorphism, right, you can actually um, get rid of all the if else and everything. You can get rid of this, right? You can get rid of this, right? So you don't have that such thing over here. We only have one actually, right? Instance of why? Because this person array, right, happen to be we are storing various types of objects, right? So that is why we need to have this, all right? Other than that, we do not required anything more, right? You don't have to put any other if else, nothing, all right? So this is the power of polymorphism, right? So you get rid of all the if else, right, by using polymorphism, right? So this is more flexible and easily you can change things, all right, if necessary in the future when you start adding more classes or more things, right? So in future, right, what I can do, right, maybe I'm just giving an example. Okay, let's say the student also has to be paid something like that, all right? So what I can do is I can actually have implements here, okay, salary calculations, and then I can have the pay here, all right, method, and then I have the implementation. So I don't have to like modify existing codes. That's what you call here, right? Open closed principle means that um, you open the codes, right, for to add new things, right? So you close for the modification of existing codes, right? So you don't actually really modify existing codes, right? You are, adding new things, right? So that's what you call open close principle, right? One of the uses of polymorphism, right? Okay, so I'm done actually, right? Here to explain all the required things, necessary things for polymorphism. Okay, so I hope you're able to understand, right? Why the polymorphism came into picture, why we need to use it, and how we can use it, and so, right? Okay, so I'd like to end the session now. All right, and thank you, and take care.